All right, we're on the third section of probability, and we are focusing on conditional probability. And the notes we're doing for this is going to cover the previous two notes that we've already done. Let's take, for example, this picture right here. And if you look at question 3, it says, find the probability of choosing a person that ate lasagna given that they ate pie. We could write this symbolically as find the probability that a person ate lasagna given that they ate pie. This symbol here is given. This is under the condition that this has already been met. So instead of our entire sample space being our 12 friends, we're only looking at the number of people that ate pie, which was 6 people. So the total number of possibilities is 6. Of those 6, how many ate lasagna? Well, that would be 5 people. So the probability is 5 out of 6. Let's check out the problem below this. Find the chance of choosing someone who ate pie. Find the probability that someone ate pie, given that that person had eaten lasagna. So we look at the lasagna circle. There are 9 total people. That's the number of outcomes. And on the top, we put the favorable outcomes. Of the 9 people that ate lasagna, how many of those had pie? Well, that would be 5. So that's 5 out of 9. This is conditional probability based upon a condition. Let's take this drawing, bring her down here so we can try to answer these questions. Find the chance of choosing a person who plays a sport under the condition that the person rides the bus. So find the probability that they play a sport given that they ride that Twinkie. Well, how many people ride a Twinkie? There are 11. Of those, how many play a sport? It's 9. So it's 9 out of 11. So we only consider those who ride the Twinkie, and of those, 9 play a sport. Let's see. The next question, find the chances of choosing a person who rides the bus. Find the probability the person rides the Twinkie under the condition that the person plays a sport. So our denominator is looking only at people that play sports. That's 14 plus 9, that's 23. Of those 23, how many of those ride the Twinkie? Well, that's 9 people, so that's 9 out of 23. These are conditional probabilities. Let's go forward to our second page of notes. Just 1 second while I grab my notes. And let's look at rolling a die. Let's say that we were asked, you're going to have to write this down because this isn't on your paper. What is the probability that a person gets a 2 given that they've already gotten a 2? So what that means is we follow the trail of they got a 2. Now we know this has happened. We know they've got a 2. So from here, so we ignore how we got there. We just are starting at this point. What's the chances that they get a 2? Well, it's 1 out of 6. Because we already have that written on this tree diagram. A different question, what's the probability that someone gets the complement of a 2, not a 2, given that they've already gotten a 2? So we start out with, we know they got a 2 initially. Now, once we know that's happened, we don't care how we got there, but what's the chances that that person didn't get a 2 on the second one? Well, that would just be 5 out of 6. So for tree diagrams, conditional probabilities aren't so bad. You follow this path, and then once you're there, you find this probability. Let's scroll down, let's see, to the one underneath of this. And let's ask a couple questions. What's the probability that you get a, what was the C stand for? Composite number given that you had rolled ahead, or flipped ahead, And let's find the probability that you have a composite number given that you had the complement of a head. See if you can answer these questions before I do. If you need to pause the video, go for it. So the condition is we got a head, so we followed this path. Once there, what's the chances that we got a composite number? Well, that was 2 out of 6, so it's simply 2 out of 6. What's the chances you get a composite number given that you had the complement of a head? Well, let me finish this diagram. So this would be 2 out of 6. This is 4 out of 6. So that would also be 2 out of 6. No matter which you flipped up first, a head or a tail, the chances of you rolling a complement, a 4 or a 6 on your die are the same. So that's 2 out of 6. Let's see, do I have other examples? I do. Let's continue here. Well, maybe I don't. Let's check out the homework that we've already done. Just show you a couple more examples of this. I meant to add these to the homework as questions and I didn't, so shame on me. So looking at a king's ransom, what's the probability that you get a king given that you've already gotten a king? Well, if we follow the king path, we've already gotten a king. It doesn't matter how we got there. Once we're here, what's the chances that we get a king? So this is the condition. That's what we're trying to figure out. Well, that's 3 out of 51. What is the probability that we got the complement of a king given that we got a king the first time? So given that we got a king the first time, so we're here right now, doesn't matter how we got there, what is the complement of a king probability? Well, that's 48 out of 51. I'd like you to add a few of these questions to the homework since I forgot to. On the tricycle one, I'd like you to find the probability of getting the complement of a 1 given that you got a complement of the 1 the first time. Probability that you get a 1 given that you got a 1 the first time. And for the heart returned, I'd like you to find the probability of getting a heart given that you got a heart the first time. Probability of getting the complement of a heart given that you got a complement of the heart the first time. For the reds, I'd like you to find the probability of getting a red given that you got a red the first time, and the probability of getting a complement of a red given that you got the complement of a red the first time. And let's just do a couple more. Let's not get crazy about it. Let's do, for one-eyed jacks, let's do the probability. Let's not do that one. Oh, that was the face cards. Yeah, let's do the face cards. Probability that you get a face card given that the first one that you got was the complement of a face card. And the second question, find the probability that you get the complement of a face card given that you got a face card the first time. And let's just end it there. So please add to your homework assignment. Just write it down right now. That question, this question, this question, and this question. I added 1, 2, 3, 4, 5, 6, 7, 8 more problems. Cool, 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 cool.